Alright guys, welcome back to day 2. Not really day, it's just episode, And my camera is really jacked up, but I'm not going to change it because it actually looks kind of funny. Um, but today guys, we're going to be expanding our knowledge a little bit with C, right? Last time we were basically just created a very basic Hello World program, and today we're going to expand on that a little bit. So yeah. So go ahead and open up your favorite command line shell and go to your programming directory. I have my little code directory here in C, and then let's see, it was what was our program called? And it doesn't matter. Video 2. So I will go ahead and real quick, I'm gonna actually introduce Make for you guys a little bit, and you can go ahead and we can do it right now. So if we want to install Make is going to be a build tool essentially, which means that we can automate running and building our program so that it makes compilation really quick, and you don't have to write as much of a command with options as required with GCC. You would just type make run and then your program would execute. So it makes things simple. So go ahead and look up Homebrew. Since if you don't have this, you might already have this. This is what I would recommend you install Make with. So just go ahead and copy this and paste it into your shell. I already have it. So, but next you want to look up Make. And actually, I think what you can do is, let's see. I think with brew, you can actually go ahead and search. Yep. So brew search, and then make. We should see make. Let's see. Yeah, right here. So make, you can actually just install it from Homebrew, and you type brew install make, and you can execute that. And I should already have it installed, hopefully. It's gonna install another. Let's see. Nope. Okay. Yeah, it registers that I already have it. That's good. I think I didn't really want to install it, but it's not a big deal. But yeah, you can run make version, I think, and it'll tell you GNU make. And yeah, basically this is a build tool. So what you use make for is to build and run your program. And the way you do that is, let's go ahead and go into our, let's make a new directory actually for our new program. Whoops. Okay, and here, there's nothing here, so let's go ahead and let's go ahead and touch or create the main.c file, and just like before, let's go ahead and populate it with what we had last time. So we had the stdio library, right? We had int main, and then we wrote printf hello world or something like that. So this is like the most basic C program. We can return 0 if we want. We save and quit. And so we have our file. Now we want to, normally when we compile and run, we do gcc -o, or not -o, we can just do gcc main.c, and then we'll have an executable, and then we can just run that executable, and we see hello world. Now this is fine and all, but to me that's a little bit too much work, and I want to be able to like do some other things. I want a file that'll execute, you know what I mean? So the way we can do that using make, which is the newly installed command we just installed, is we can make something called a Makefile. So to do that, you create a Makefile, just the name with a capital M, Makefile. And you'll see it's underlined because it's actually something important. And we can go ahead and go into the Makefile. And make is a lot like bash, a bash script, in that you're actually running command line commands in a script basically. And what you can do is make labels for certain commands. So you could do, for instance, run would be a command, or would be a make command. And let's just make a very basic example, right? So we do the name of the command and then colon, and then we can, underneath that, we can run some shell commands. So for instance, I could put hello world. And I think this would work. So save and quit, and then we can just use the make command and then the label name, which was run. And it's going to print out all the commands it runs. And then we see it did indeed execute hello world, the echo command. So if you can't tell already, this actually allows us to do a lot of automation because it's a lot like Bash, right? So let's go ahead and go back into our Makefile. And so I want to make something that, and I only really know the basics of make and Makefiles, but I'm just going to show you, I'm going to give you the bootstrap code to get up and running with compiling and running your programs, okay? So let's go ahead and make a build command. And basically what this is going to do is this is going to compile our program and put it in a directory called build, just to make things organized. So the way we do that is we compile it like regularly with GCC, and then we move, or first we want to create the directory, right? So we create the directory build, okay? And then we move, so we go ahead and move our a.out file into build/a.out. And this should work, but there's going to be an issue, okay? So let's go ahead and rm our a.out that's in our directory right now, and let's run make build. And it looks like everything worked, right? We can ls build and see that our executable is inside that. Now the thing is, if we want to build again, which you should be able to do, right? You should be able to build normally with a normal build tool. That's what you'd be able to do, is just you can run the command again without issue. But you'll see that our build is up to date. So to me, I don't really want to do that, right? I want to be able to just, like, every time we update our code, I want to be able to build it, right? But the way we can fix this is going back, and that's kind of what make is made for, is that you want to only execute commands when certain dependencies are changed, just so it streamlines the process. But we want to make a dependency change here. So, or no, what we want to be able to do is clean, right? And that means we can make another command called clean. And all this is going to do is basically just remove the build folder so that we can run that command again. So the way we do that is rm recurs and force, and then we're just going to run, don't do / make sure you make it relative or something. So current directory build, and that should work just fine. So let's give that a go. Let's go ahead and write and quit, and then so we have our build folder, and if I want to just like get rid of it, I can do make clean, and you'll see that that got rid of the build folder, and then I can do make build, and then we have it again. So that actually makes it pretty nice, right? We can clean and build, and what we can actually do is, going back to our Makefile, we can actually make it so that this build depends on clean, and what that means is that clean will always be run before build, like automatically. So if we run, let's see, so we have build right now, and before I would have said, oh, okay, it's already up to date, I'm not going to recompile, but if I do run build again, you can see that actually in the response, you see that it actually cleared build first. It ran the clean command first, which is what we wanted. So that's really nice. And maybe you want something like make run. Make run would be nice. And here we actually got to see something, because I didn't actually know what it was called, but these are not called commands, they're called targets. So that's a terminology for you. So if we go back into the file and we make a new target called run, we can actually go ahead and clean, or we can build, and then run will depend on build. It'll make sure build is ran first, and then build will make sure clean is run first. So you can kind of see how you can build a structure here. You can build a sequence of commands. So run is going to build, and then we want to be able to, all we want to do is just execute, right? We want to execute that file. So the way we do that is from the root, we're going to simply just run the program, and we should be able to do that with /build a.out. I think we should be able to do that. So let's see. So make run, and you see it worked. So that's a really nice way to just streamline development with C. So we can, if we want, we can make clean, and yeah, it's just really nice way. It's a way to standardize, and a way to standardize your projects with C. You can make your own template repository, and then that's what this is, right? If we vim into my custom script, this is what I'm doing. This is just error checking, but I'm actually cloning a template, a C make template, and then I'm just removing the Git project because I don't need to clone it. I don't need to like update, and I want to be able to make like my own repository, so I get rid of the .git, so it's not initialized. And then yeah, I mean, it's just a new program essentially. So I can do like make C, and then a project name, so proj or something. Let me see, it's cloning from GitHub my template. And then we have everything. We can just make run, and everything works nicely. So yeah, that's really nice. I mean, that's just a really nice way to work with C, and I find it streamlines development nicely. So I recommend you use that. You can even use my template. I think it's public. But yeah, so let's see. I want to get rid of the proj folder. Okay, so that's enough of Makefiles, right? I want to be able to learn some C. That's what I came here for. So let's go back into main.c. And I'm actually going to go ahead and start using AstroVim, which is just a really nice NeoVim flavor, and it'll tell you a little bit about functions and stuff, so it'll help us. But yeah, this is a very basic program. So some things you can do. If you want to create like a variable, right? Let's say you want to create a variable, like int a is how you would create variables. And you want to always put the type first, and then the name, and then you can assign it like a value. And int here stands for integer, and this means that this is a signed integer, which means it can have a sign. So it can be negative or positive. And that's important for the bit representation. But that's something else. But there's multiple names for the same type in C. So for instance, you can have signed, which is the same thing as int, so is signed int. So it's kind of funny how they do that. But there's a lot of different types, and pretty much every type, every value in C is going to have some sort of numerical representation. So for instance, I could create a char here, and char stands for character. So I can represent it like this: char equals single quotes a, okay? And I can print this out. And so like before, I guess we didn't really go over that. So this right here is something called a format specifier. So I'm basically specifying the format I want to be able to print a variable as, and that's the parentheses C or %C sign here. And %C stands for character. C stands for character, and that means when I actually run the program, we'll see we actually do get the letter A printed to the console. And if I wanted to convert it to like a digit, I could get the ASCII representation for the character A, and that would be 97. So this is how you use printf, I guess, with variables. And if you want, you can do a little like math with them, I guess. Or I guess, let's see, what do I want to talk about? So yeah, there's also another directive, another library here that gives us access to another type, and that's called a Boolean type. So C by default doesn't actually have Booleans, which represent true or false. So we have character types, and now we have Booleans. And so the way you can you would include this std bool header file to be able to use this bool type. Okay, and we can also just write true or false now. So this represents like if things are true or false, right? It represents a condition. So like for instance, you could also have here A is less than 97. We saw that it actually equaled 97, so this should be false. And if we were to print out that value for Boolean, there actually isn't a way to just like write true or false to the console. It's always going to be, like I said, every value in C is a number. So bool is going to be this right here is the value, right? And it evaluates to false because the ASCII value of A is 97. It's not less than 97. So false as a Boolean is represented as 0. So we'll see when we print this out, it's gonna return 0. Okay, and that is, if we wanted to say something like, does it equal 97? We would put 2 equal signs to represent a like a quality check, and then we can run our program again, and we see we get 1 for true. So we can also represent strings in C as well. And the way we represent strings in C is there's multiple ways to do it, but I'm going to talk about char arrays. And you can also specify them with something called pointers. But with arrays, an array is just a contiguous sequence of characters, or a char array is. A regular array is just a continuous sequence of bytes, but of memory addresses, really. But the way you would do this is to create a char array, a character array. You have the same type as char here, but then when you specify the name, but then you put brackets, and then you specify the length of the string, which is what we're talking about. So I'm actually not going to specify the length because you don't have to. It's actually, if you're going to put a string literal, which is what the double quotes are here, this is a char literal because it's single quotes. A literal is just like the actual value. So anything on the right hand side of the equal sign, the assignment. But here I'm going to say, hey, this is my string literal. And C, the compiler, is going to be able to interpret this string literal and then tell you, or it's going to be able to derive the length of the array. And the way we can check the length of the array is by using, well, we're going to have to include another library. We're going to include the string library using the string header here, or we're going to use it. And the way we can figure out the length of this string array, or char array, is by using something called strlen, which is exactly what you would think it sounds like, right? The length of the string. And we're using ZU here to represent a type called size t, which is the type that is which is the type of the value that is returned by pretty much any like size of something. And we'll get to the size of operator soon, but just know that, I mean, I could just use D here. It's not a big deal, but just know that that's what's being returned when I use strlen. Okay, and we're going to pass in our newly created string, str, and, well, I got to fix this. Whoops. And I guess it is complaining, so maybe we do have to use the right format. But we can actually, in my IDE, I guess, editor, I can actually check what the return type is here by pressing Shift K. And as you can see, it actually returns an unstringed long, but that, I mean, that's essentially the same thing. So yeah, I mean, now what we can do is we can run our program and see, well, it's printing out 1 for the B Boolean right here. And then it's printing out, the length of this, which is 3, right? This is 3. So the way we can separate that is by just adding a new line character. And we can run it again. And I'm going to increase the size here actually real quick. You can see that we have 1 for true, which is from this Boolean B, and it's true because we're saying the ASCII value of character A is equal to, is it equal to? It's like a condition. It's a question. So is it equal to 97? Well, the answer is 1 or true. And then we're also printing out the length of this string, hey, and we see that we do indeed get 3, which is the amount of characters. So that's very basics of C and types and variables. If you wanted to like change a variable, what you would do is you would write the variable name and then the assignment operator, and then you could write a new value. So we could write B, we could reassign A to the character literal B, and then we can also print that out if we wanted. And for characters, again, it's %C, and we write A, we save, and then we run, and we should see a B here, making sure it's on a new line. And if you, when your program becomes more and more complex, sometimes you want to be able to restrict yourself and make constants or variables that are cannot be reassigned, right? So A is a mutable variable because we can reassign it, we can mutate it. If we wanted to make it immutable, we would put const to make this a read-only variable. And now you can see we're getting an error. We can't actually reassign this. So that's a nice way to restrain your coding a bit, and it really helps when you're making, bigger projects. And it helps with just thinking about things, making sure that things aren't changing, and you can actually reason about your program faster when you use consts, if it's a larger project. But yeah, that's the very basics that I want to go over. Just a few things about types, variables, and strings, and one function, the strlen function. So yeah, we'll come back next time and we'll be learning more about arrays and strings.